You ever get the feeling that there's more to numbers than meets the eye? Well, you're right. Today, we're going to crack a secret code that's hidden inside the numbers we use every single day. It's a fundamental relationship that, once you see it, is going to give you a whole new way of looking at how numbers are connected. So let me just ask you this. What's the secret link that connects any two numbers you can think of? It sounds a bit like a riddle, right? But the answer is just, well, it's beautiful math. And by the time we're done here, you're going to see it clear as day. Okay, so the key to this whole thing comes down to one simple idea. Every whole number you know is actually built from a unique set of smaller prime numbers. You can think of them like Legos, or even better, like the number's unique DNA. These are its fundamental building blocks. All right, to really see how this works, let's get our hands dirty. We're going to take two numbers, nothing too crazy, let's say 6 and 20, and we're going to break them down into their most basic parts. Okay, let's do this. Step 1, find the prime building blocks for 6. Step 2, we do the exact same thing for 20. Simple as that. And there we go. Check it out. For 6, it's super simple, just 2 times 3. For 20, it's 2 times 2 times 5. Now pay close attention to that last column, the exponential form. Instead of writing 2 times 2, we just write it as 2 squared. That little detail, it's going to be a huge deal in a second, so keep it in mind. Okay, so we've got our building blocks all laid out. Now comes the fun part. We can use these little prime pieces to build two really, really important things: the highest common factor, or HCF, and the lowest common multiple, the LCM. And this is where you can really see the difference between the two. For the HCF, think of it as a very exclusive club. We only look at the prime factors they have in common, and we take the smallest power of those. But the LCM, that's a party everyone's invited to. We take every single prime factor involved, from both numbers, and we pick the greatest power of each. All right, let's put that rule to the test. For the HCF of 6 and 20, what's the only prime factor they share? Yep, it's the number 2. And what's the smallest power of 2 we see? Well, it's just 2 to the power of 1. Easy. So that's it. The highest common factor is just 2. That's the biggest number that can divide into both 6 and 20 without leaving a remainder. Okay, now for the LCM. Remember the rule? Everyone's invited. So we need every prime factor we saw, 2, 3 times 5. And for each one, we pick its biggest, greatest power. So for 2, that's 2 squared. For 3, it's 3 to the 1. And for 5, it's 5 to the 1. And what happens when we multiply all those together? 2 squared times 3 times 5 gives us 60. And that right there is the smallest number that both 6 and 20 can divide into perfectly. Okay, let's pause for a second. Our HCF is 2. Our LCM is 60. So what? You might think this is just a math problem, but this is where the magic happens. Watch what happens when we put these two answers together. It reveals something. Well, something kind of incredible. So, I've got to ask, what happens if we just multiply them? What do we get when we take our HCF, 2, and multiply it by our LCM, 60? Okay, 2 times 60, that's 120. Got it? Tuck that number away in your brain for just 1 second. All right, now for the other side of this. What happens if we go back to the very beginning and multiply our two original numbers, 6 and 20? Would you look at that? 6 times 20 is 120, the exact same number. And let me tell you, that is absolutely not a coincidence. What we just stumbled upon is an incredible universal rule of math. It works for any two positive numbers you can dream up. Take their HCF, multiply it by their LCM, and you will always get the same answer as when you multiply the two numbers themselves, every single time. Now, this isn't just a cool party trick, right? This is something really fundamental about how numbers are put together. So let's break down why this actually matters. So, what's the big takeaway here? Well, for one, it's a fantastic shortcut. I mean, if you've got two huge numbers and you've already figured out their HCF, you can find their LCM in a heartbeat, without all that extra work. But honestly, it's more than that. It shows us this hidden, perfect symmetry, this beautiful, elegant balance that's baked into the very structure of numbers. And that really just leaves you with one final thought, doesn't it?
If a rule this simple, this elegant, connects any two numbers, it just makes you wonder, what other hidden patterns, what other secret codes are still out there, just waiting for us to find them?